When you are unit testing an ASP.NET MVC application, you'll probably want to unit test your controllers. The easiest controllers to test are the controllers that do not have lots of complicated logic inside of them. Controllers are not the place to put business logic. And once you have a controller that's over 10 lines of code, it's time to take a step back and ask if the action is doing too many things. You can usually make controllers smaller by creating a real business layer that does work for you. Then the controller simply becomes a delegator. You receive a request in the action and receive all the parameters that are in that request and simply forward the call to the business layer that gives you back some results that you transform into some sort of action result. The application I'm building is relatively simple, and I'm not going to build out another layer for the application, but I do want to show you some general approaches to unit testing controllers. The first thing you'll want to think about is how to isolate your controllers from all the services and databases that they need to do the job, like the Ode to Food DB that we're using here in the reviews controller. If I want to unit test the index action, I'd have to have a real database server in place, and my unit test will be slower than if I had the capability to replace that Ode to Food DB with something that we call a test double. A test double could provide this action with data from in memory and let the unit test run very quickly. It also isolates the controller then from all these infrastructure dependencies that it might have, like network connections to a database server. We wouldn't have to worry about setting any of that up. And in this scenario, Ode to Food DB is working against a database, but imagine that being a class here that just represents a business service or a WCF service or anything like that. Not all teams are willing to do this, that is, use a test double to provide in-memory fakes to isolate controller actions and to isolate the classes under test. And there are pros and cons to using test doubles. I want to show you in this module, though, how to use test doubles. So the first thing I'm going to do is to create an abstraction over Ode to Food DB so that the controller doesn't really know what it's accessing when it executes queries like db.reviews.findthelatest. Inside the web application, I've defined a new interface, IDBContext. This interface represents everything the application needs to do with the entity framework at this point, and that includes getting to a queryable sequence of restaurants and reviews, the ability to save changes, and the ability to add, attach, and delete entities. The difference between add and attach is that add is what you'll do when you want to save a new object, while attach is used to update an entity that is already in the database. We'll see how that works in just a minute. And now the reviews controller itself no longer works with Ode to Food DB. All of the controller actions work with an IDB context. And with the DB context, the actions can still do all the work that they need, like querying for the most recent reviews or finding the best reviews. As far as the action knows, the reviews property is still iQueryable, so it can call any extension method defined for iQueryable, and that includes a custom extension method that I've been using named findthelatest, but that also includes any of the standard link operators. So I can say db.reviews.orderby or db.reviews.where. All of the standard link operators are still there. And as we'll see, this IDB context, now that we're programming to an interface in this controller, that will let me provide fake data to the controller action at test time. That makes the tests faster, also means I don't have to worry about setting up a database just to execute the unit tests. But before we look at the test code, what happens when the code is running on the real web server? In that case, the class behind this IDB context abstraction will be a real Ode to Food DB object, the same Ode to Food DB object that we have been using in this application. You can see that it still derives from the Entity Framework's DB context class, but it also implements my IDB context interface, and it does so explicitly. And that's mostly because I wanted properties like restaurants and reviews to be iQueryable instead of DB set, and that's because iQueryable is much easier to test. Notice all the implementations for the IDB context interface simply forward their calls to the underlying DB context object, so there's no hard work being done here. I simply put a more testable wrapper around the DB context class, and in some cases it's simplified the API. For example, in this attach method, using the Entity Framework API, I'd have to call the entry method and then set this entity state property, but now all a controller action has to do to update an entity is call attach. We can see attach at work inside of the reviews controller when someone posts an updated review that we need to put into the database. In that case, we just take the review as a parameter. The model binder will populate it with all the values that the user put into there. We call the attach method to ultimately tell the entity framework that here's an object that's already in the database. You just need to make sure to save all the values that are inside of it. And it's a very clean API at this point. And one question you might have is, how does this reviews controller get a real ode to food DB object in this _DB field? And the answer is that for right now, I've given the controller two constructors. We're going to change this later, but for right now, I still have a default constructor, and it is just going to set _DB to a new ode to food DB object. So by default, when this controller is instantiated by the MVC framework, it's going to be working against the database. But I have another constructor that takes an IDB context parameter, and in that case, when the controller is constructed, it's going to take whatever we pass into that constructor. And what this constructor will allow me to do during unit testing is pass in an in-memory context. So let's take a look at how the tests can work. First, here is a fake DB context. The idea here is that I can have an object that looks just like something that talks to the database. It implements the IDB context interface. But in fact, all of the data being queried from this context or added to this context is going to be in memory. Specifically, the objects coming in will be stored ultimately in a hash set of T from the system.collections.generics namespace. And we can make that in-memory data look like it's something from the entity framework by using the asQueryable link operator. AsQueryable makes any IEnumerable of T look like an iQueryable of T, just like it would if it was coming from an entity framework DB context class. And there isn't much code inside of this class. I've essentially built an in-memory database with 70 or so lines of code and some C# generics magic. Of course, it doesn't really do much, but it does enough for me to have unit tests without a database. Essentially, what I want to test is that when I invoke the index action of the reviews controller, I want a model coming back that has 3 reviews inside of it. So to test this scenario, I'll create a fake DB context and populate it with 4 review objects. And now, one of the nice features of the MVC framework is that the controllers themselves can be very easy to test as long as you keep testability in mind. The controller is just a simple C# class, so I can instantiate it. The action is a regular method on the class, so I can invoke it. And the action itself doesn't try to render HTML or do anything that requires a web server or a network connection. It simply returns an action result. The test pulls the model out of the action result, in this case it's a view result, and then I can write an assert to make sure the model has 3 reviews inside. And the test that you're looking at here is generally the type of code you want to write for testing controller actions. It follows a well-established pattern of arrange, act, and assert that you can read about if you are new to unit testing. First, you arrange the objects required for the test. Then you act on something, in this case by invoking the index action, and then you can write asserts about what that action produced. What you want to avoid in unit tests is trying to test the code that you don't write. So I don't have to test that the MVC framework will process the view result properly. That's beyond the scope. That's something that the MVC framework takes care of. I just need to test that the view result was properly populated.